Hey class, just wanted to continue with page 9. So this is still in section 5.3. These are the word problems. This first one, you have the tests are normally distributed with a mean of 50 and a standard deviation of 10. And then the agency will only hire applicants with scores in the top 10%. What's the lowest score you can earn and still be in the top 10%? So think of this on normal distribution. So if I just draw it out, a rough sketch of it, the top 10% would be the top 10% under the normal distribution. And so the idea is, what is this score right there? Think of this as a two-step problem. First, like on page 8, figure out what that z-score is. And then we're going to convert that z-score into a raw score using a formula. So first step, let's see if we can get that z-score. And that is StatCrunch. So let me bring up StatCrunch and see if we can find it. So top 10%, I go to my stat calculator, normal. Remember, this over here is area, so I'm going to put the 10% there. And then this is the bottom 10%, obviously. I got to get that inequality the correct way. And then re-put in that. So here it is, greater than and a 0.1. That'll give me that z-score. Okay, so that z-score is 1.28. So I can go back to my problem and work that out. So let's see. Okay, so I have the z is 1.28. And again, that was using StatCrunch. Now there's a formula that converts z-scores into raw scores. It's x equals z times sigma plus mu. That's really a rearrangement of the z-score formula algebraically, but use that formula for this section. So if I plug in these numbers, the z is 1.28. The sigma was 10, that's the standard deviation, and the mean 50. And if I calculate that, I'll get my final answer. So that's going to be 12.8 plus 50 is 62.8. And we're done. So the lowest score to be in that top 10% is 62.8. Cool. Let's try another one. Qualify for the national marathon. Runner's time must be in the fastest 10%. Think of that as, so that fastest 10% is actually smaller or lower times, right? Because lower time is fast. You do a race in 1 minute, you're doing it better than if somebody did it in 2 minutes. So I'm thinking that fastest times is actually down there, right? That's the fastest 10%. Okay. And then we're given a mean and a standard deviation. Find the slowest time right there and still be in the fastest and so qualify for the race. Okay. So this one I could do StatCrunch again. If I do it, it's similar to that last one. It's going to be negative 1.28. So you can try that with StatCrunch. Just use the less than sign, right? Or use symmetry. The top 10% was a positive 1.28. So the lowest 10% would be a negative 1.28. And then go to your formula, x equals z times sigma plus mu. Negative 1.28 times the standard deviation 23 plus 258. All right, and then I'm going to get my calculator and just do that all at once here. And This is approximately, if I do 1 decimal place, I'm getting 228.6. That's in minutes. There's your final answer. Okay. So that's how those work. One more we can try here at the bottom. Has like percentiles and quartiles and that sort of thing. So in a survey of women in a certain country, mean height 65.1 and a standard deviation 2.82. Okay, what's the height that represents the 90th percentile? So if you can draw these out with a little sketch, it does help. Remember, 90th percentile is 90% to the left. So percentiles are always area to the left, right? And so what is this 90th percentile score? Okay. If I think about that, 90% to the left, 10% to the right. If I go to StatCrunch, my z-score on that one is going to be that 1.28 again, right? So you can do less than 0.9 or greater than 0.1. Either way, will give you that same z-score. If you try that in StatCrunch, you'll see it. Okay, and so I can calculate my x. It's going to be the z-score times the sigma, 2.82, plus the mean, 65.1. Okay, if I calculate that, that's about 68.7. Okay. Next one, what height represents the first quartile? Okay, if you remember quartiles from chapter 2, quartiles are 25% increments. So that first quartile will be a 25% to the left. So we need to do StatCrunch to find that z, right? So let's bring StatCrunch up again here. And try it out. So it's a less than, so I'm going to go left for less than, and then I'm going to put in my 0.25 and then see what I get. So z is going to be negative 0.674, let's call it. Okay. I look at the picture, it looks good. Looks like the picture I drew. And so I can go back to my handout and continue with this one. Okay, so get your formula out again as this thing switches over. And what are we going to do? We're going to take that z-score, multiply by the standard deviation, add the mean. That same structure there. Okay, sorry for the bad handwriting. Doing my best. Okay, so I'm punching this in. And that's looking like about 63.2. Okay, rounding to 1 decimal place on that. And these are all in inches, right? So these are raw data values, so inches to be clear. And then finally, what two heights does the middle 50% of the heights lie? Okay, so drawing that one out, middle 50, right? 0.5. Now, if it's the middle 50, over here is 0.25, and over here is 0.25, you could use those facts, or just go right with that middle 50 and use StatCrunch. You could use that between option. So going back to my StatCrunch, and let's put that in. So middle 50, I'm going to hit the between option, and then 0.5, oops, one extra decimal. Right. There's your middle 50%, okay? And I'm getting these negative 0.6745 and 0.6745, all right? So I'm writing that down. 6745, I feel pretty good about that. So let's go back to the handout and complete it. Now notice on this one, you're gonna need two answers, right? Because it says between what two heights does the middle 50% lie? So we have a negative 0.6745 and also a positive 0.645. We have to do that formula for each one, right? So my first one, negative 0.6745 times the 2.82 plus the 65.1. Right? Okay, so that's approximately 63.2. Pretty much the same thing we did in B, right? I mean, same calculation there. And then the other one is just without the negative. Let's see if we get there, 0.6745 times 2.82. That's about 67. Okay, and both of those are in inches, and we're good to go. Okay, so that'll get you through 5.3. One more thing, I can show you the super sneaky, extreme StatCrunch shortcut. So let's redo, for example, problem 5. All of these can be done this way. I mean, we did all of these with that two-step process, get the Z and then the X. But remember, in StatCrunch, you can change that 0 and 1 to whatever you want. So let's try number 5 again and see if we can get the answer directly with StatCrunch. So what I'm going to do, I'm going to go standard. So for that number 5, remember it was the top 10%. And now I'm going to change these means. But the mean was 50, and the standard deviation was 10. Right? Top 10 is greater than, and then I'm going to put in a 0.1 there and compute it. Okay. So that gives you the answer directly. Our answer was 62.8. Final answer for number 5. Right? So I could do that for all of these real quick. Number 6, the mean was 258. Standard deviation 23. It was the bottom 10%. .5. All right, we got 228.6. We had a little rounding error, so that's why it's a little off, but still pretty good. Number 7, the 90th percentile one. That one I would put the mean. Let's see, the mean was 65.1. Standard deviation was 2.82. And then it was the bottom 90%. There's that 68.7 that we got. Okay, that's the 90th percentile 7A problem. First quartile was the same mean and standard deviation, but a less than for a 25%. There's that 63.2. And then the between two heights, the middle 50, put between and then a 0.5, and then compute it. And there's the 63.2 and the 67. Okay, so that makes me feel more confident in all of my by hand calculations.